Welcome back to Math for Technology. We're going to move on into chapter 14, but we're only going to do two sections. We're going to do sections 14.1 and 14.6. So in this video, we're going to talk about 14.1, imaginary and complex numbers. So before we get going too far, we're going to take a question that we already know, such as x squared plus 2x plus 10 equals 0, and we're going to solve it with a method that we already know. So we're going to take that quadratic equation and use this quadratic formula to solve it. So if you remember, the a is the number in front of x squared, so that's 1. B is the number in front of x, so that's 2. C is the constant or the number by itself, so that's 10. The quadratic formula, I'm going to go ahead and write it down. Opposite of b, plus or minus the square root, b squared minus 4ac all over 2a. So the opposite of b would be negative 2, plus or minus the square root, 2 squared minus 4 times a times c, all divided by 2 times 1. So I'm going to go ahead and just do this ourselves. 2 squared is 4. 4 times 1 is 4. 4 times 10 is 40. 2 times 1 is 2. Got a little carried away with my square root sign. I'll make that a little bit shorter. So I still have the negative 2 plus or minus. 4 minus 40 is the square root of negative 36. And I still have the 2 on the bottom. So at this point, we are usually doing the square root of whatever's in that square root sign. In this case, that's negative 36. Well, we know that the square root of 36 is 6. But if you try and do the square root of negative 36 on your calculator, it's going to tell you it's an error. And so we need to think about, what does the square root symbol talk about. So if you square root something, it is asking you what number times itself is that number. So what number times itself is 4? Well, 2 times 2 is 4, so that's an option. But it is also true that negative 2 times negative 2 is 4. That is also true. So true, true. But how would I make and get a negative 4? Well, if you think about it, the only way to get a negative number when multiplying two numbers is to multiply a positive and a negative. So it would have to be a negative 2 times a positive 2 in order to get a negative 4. Well, that is not what a square root is asking, because that is not a number times itself. That is a number and its opposite. So when we're square rooting a negative, we're asking it to do something that is against what it is asking you to do. So we're essentially asking it to do the impossible. So for a long time in mathematics, they left this as their answer. They just circled this and called it good, was done. And then after a while, they decided that wasn't okay. And in fact, Euler was the one that said, we have to do something with that. And so that's where they came up with a letter. So on all of these examples here, we're going to talk about that. So what they did was they took this negative out. And they said, well, the negative is what's causing the issue. So if we separate it, we have the square root of negative 1 times the square root of 36. We took out the issue, the square root of negative 1. The square root of 36 is 6, so we could say this is our answer. And they moved to there. Well, this still was some more than what they wanted to do, so they came up with a symbol for this idea here, this square root of negative 1. And the symbol that they came up with was the letter I. Now, we're in Math for Technology, and the letter I is used for current. And so we can't use the letter I because of that. In academia, where they're just worried about theory, that's all good and fair because then I can be this number. But if I'm working with multiple disciplines, then I have to be able to accommodate them all. So we're not going to use the I to represent this square root of negative 1. In fact, we're going to use the letter J, since I stands for current. So in our textbook and in this video, you will see using the letter J. So what they did is instead of writing the square root of negative 36, we've now simplified it into just 6j. The j represents that we originally had a square root, and then the square root of 36 is 6. So it represents both parts. So knowing that, we could go back up to the previous question, and let's think about what it says there. So we have negative 2 plus or minus. We know that the square root of negative 36 is 6j over the 2 on the bottom. Well, both the 2 and the 6 can be divided by 2, so we can go one step farther. Negative 2 over 2 plus or minus 6 over 2j, or negative 1 plus or minus 3j. So this can be broken off into our two answers, since all quadratics have two answers. Negative 1 plus 3j, that would be one answer, and negative 1 minus 3j, that would be the other answer. These are called conjugates. Notice they're the exact same answer except for the middle term. And so anytime you're dealing with imaginary numbers or the j numbers, then this symbol right here in the middle, that's the one that changes, that's the conjugate because of the plus or minus idea. Okay, so let's go back and just simplify some of these before we keep doing the actual solving. So negative 2.25, we're going to separate it. We'll pull out the negative. We'll just put a 1 with it as a placeholder. Then we have the square root of 2.25. So we know that the square root of negative 1 is our j. So the square root of 2.25, that is our 1.5. So 1.5, that's the square root of 2.25, and we show a j to represent that we did have a negative underneath the square root. We're going to keep going with that theme. Square root of 24, so I need to break this down. 24 in itself, nothing times itself is 24, but there are some squares within it. So I have the original negative 4 outside. I have the square root of negative 1. Now, 24 is the same as 4 times 6. And the reason I chose to break it into 4 and 6 is I know that 4 can be broken down and the square root of 4 is a whole number. Square root of 6 is not, but that's okay. I'm just trying to get at least one out. If I tried to use 2 and 12, because 2 times 12 is 24, but 2 times 12, I can't take the square root of 2, that's not a whole number, and I can't take the square root of 12, that's not a whole number. So I don't want to use this one. I want to use one where I can at least break it down. So square root of negative 1 times square root of 4 times square root of 6. So 6 times 4 is the 24, 24 times the negative 1 is the original negative 24. So I have the negative 4, I have the square root of negative 1, that's my j, I have the square root of 4, that's 2. Can I take the square root of 6? No, it's not a whole number. I can't break it down because it's 2 and 3. Neither one of those can be taken out as a whole number. So that part's going to actually stay within the radical. So negative 4 times 2 is negative 8, and then it's the square root of 6. Make sure you put the j on the outside. It is not inside the square root sign. That would be a whole different concept. Now as we keep going, we can do that within fractions. So we have the square root of negative 1. We have the square root of 36 and the square root of 49. So I just give them each individually their own. Square root of 36 is 6, square root of 49 is 7, the square root of negative 1 is j. So you can just break it down into parts. Again, I have the negative 5 already on the outside, so I'm going to leave it out there. Square root of the negative 1, square root of the 16, over the square root of 25. So staying in the numerator, staying in the denominator. I have negative 5, square root of 16 is 4, square root of 25 is 5. Notice I still kept the fraction. Square root of negative 1 is j. On this one, I'm going to go ahead and simplify first. So 5 goes into 5 one time. So essentially it's canceling, giving me still have the negative, the 4, and the j. Now, j's in themselves can be just like any number. You can square them, you can cube them, you can fourth them, you can do any power to them. So what I want to think about here is this is j is the square root of -1. So what this is essentially saying is taking the square root, I'm going to erase that, that wasn't looking very good. Let's try that again. I'm going to take my square root of -1 to the 9th power. Well, let's start simple. What if I did -1 squared? Well, -1 squared, the squares would cancel, and that would leave me with -1. But that's not what I'm really doing, right? So I have to come up with somehow I got to get this all the way up to the power of 9. So you have to know your exponents. Square root of -1 squared can be then multiplied by the square root of -1. How many do I have left? I have 7 of them left. I can break that down. I'm going to write this out nicer so you can see. Okay. So I have a square. There's 2, 4, 6, 8, and then I'll squish this last one in here, 9. So 2, 4, 6, 8, 9. So there are my 9 square roots of -1. If I square the square root, these simply cancel, leaving me with -1. Same thing here, leaving me with -1. Same thing here. Same thing here. Now this I didn't do anything to it, so it's still the square root of -1. A negative times a negative is a positive, so this is a positive. Negative times a negative is a positive, so I have 1 times 1 times, this is your j. 1 times 1 is 1, 1 times j is j. So this j to the 9th is exactly the same as simply j. And so you want to try and break those down into pairs. If you might try bigger numbers and see if you can figure those out. But you want to get it down as far as you can. You should never have a j that is bigger than the power of 3. Actually, you should never have a j bigger than the power of 1. Okay. If you want to go into more detail on that, let me know. On this next one, I have a square of the square root of -21. So just like up here, if you square a square root, squaring a square root cancels. So this is just -21. I like those. They're nice. Now, if you have two things within like radicals, you can combine them. So I'm actually going to multiply this 3.6 and -3. So what I essentially have is -3 times the square root of -3.6 times 3 is 10.8. So there's that. Well, I can see the negative in the square root, so I can tell right away I'm going to have a j. Now I have to think, is there anything in 10.8 that is a square? So my squares are 4. 1 is actually a square, but it doesn't help us. 2 squared is 4. So I could check, does 10.8 divide by 4? And it does, it's 2.7. So we can go ahead and break that out. That was kind of nice. Now, does 2.7 divide by anything? Square root of 4, or does it divide by 4? No. 3 squared is 9. 2.7 does divide by 9. It takes me down to 0.3. So we're going to go one more step. -3 times the square root of -1 times the square root of 4 times the square root of 9 times the square root of 0.3. Now, I broke that down a lot. I went from 10.8. I broke the 10.8 down into 4 times 2.7. Then I took the 2.7 and I broke that down into 9 and 0.3. Now you can check if you multiply the 0.3 times the 9 times the 4 times the negative 1, you should end up all the way back to negative 10.8. So now I'm going to break these down individually. So we still have the negative 3. The square root of negative 1 is my j. Square root of 4 is 2. Square root of 9 is 3. Can't break this one down anymore, so it's going to stay 0.3. Negative 3 times 2 is 6. 6 times 3 is 18. So it's negative 18 square root of 0.3 j. So I'm taking as much as I possibly can out of the square root, so I have just something inside of there that is not divisible by any kind of square. Okay, so the next one is being multiplied. It looks a lot like the distributive property, so hopefully that was an instinct that was coming out. 3 times 5 is 15. 3 times 6 is 18. So this is just teaching us that it doesn't matter if you have something with a j or not. If not, if you're multiplying, you can just go ahead and multiply through. So I have a similar one, but notice on this one the outside has a j in it. Still going to just do the distributive property. Negative 4 times j is negative 12j. Negative 4 times negative 4j times negative 6j is a plus 24j squared, because j times j is j squared. So let's think about what j squared is. J squared is the square root of negative 1 squared. So I'm squaring a square root, which means that cancels. So j squared is really the exact same thing as just negative 1. So I have a negative 12j plus 24 times negative 1, which becomes negative 12j minus 24. And to write this properly, we always write the real part, which is the part without the j, in front of the part with the j, so it should be negative 24 minus 12j. So this is the same as what we started with. Okay, we're going to break this next one down. The only difference is it's in a fraction form. So I'm going to just mess with this square root of negative 28 and see how small down I can get it to start with. So I'm going to ignore the rest for just a moment. So that is the square root of negative 1. That takes care of that. Then I have the square root of 28. I'll try breaking this down, showing you step by step. So again, if I go back to the idea we had here, with 1 to go into it, but that's not helpful, so then I'm going to try 4. 4 definitely goes into 28. So this is the square root of 4. 28 divided by 4 is 7. 7 itself is a prime number, so nothing else is going to go into it. So the square root of negative 28 is going to break down into j times 2 times the square root of 7. So now I'm going to put it back in its fraction. So the back in its fraction is 9 minus, because that was a minus, 2 square root of 7j, all divided by 3. Now you can pull them apart and separate them like we did, where did we do that? Way back up here in the beginning, where I broke this negative 2 over 2 apart and the 6 over 2 apart, if they're both divisible. So let's look. 9 is divisible by 3, but 2 is not divisible by 3, so it would not benefit us to do that. So we're just going to do that. All we could do was break down the 28. Okay, so the next one is just like the one that we did at the beginning of this line. The only difference is it doesn't have a j with it, so we're just going to distribute. So negative 10.8 times a negative 0.36 gives us a 3.88. 8 minus negative 10.8 times 2, it'd be a 21.6j. Okay, so a couple more, and then we're going to go back to those ones like similar to the top. Sometimes they'll ask us to take two parts that are complex and equally them each other and find their parts. So I have a complex number equaling a complex number. I have the real part, which is the part without the j. That's the x on this left-hand side. So I come over to the right and I say, what's without the j on the right? And the part without the j is the 8, so x must equal 8. Then I take the part on the right, which is the yj, that is with the j, and I equal it to the part on the left. I have that backwards. The yj is on the left, the negative 3j is on the right. You can tell I'm still getting over my sickness. My brain is still foggy. So the j's are the same, so that part's not any different. So what about the rest? If the j's are the same, I can just get those out of there. They cancel, so that tells us that y has to equal a negative 3. And I know that because this side, the left-hand side, is equal to the right-hand side. Okay, so we're going to come over here to this next one and do very similar. We're going to work with what's with the j, the imaginary part, and what's without the j. So this 3/7 is not with the j. The 2 is not with the j. So that must equal the 6, because that's not with the j, and that's it. So there's the equation that we're going to solve. So we're going to go ahead and minus 2. So we get 3/7 equals 4. I'm actually going to multiply by the conjugate. I'm sorry, by the reciprocal. We're going to flip this over. That way these cancel. 4 times 7 is 28. I can leave it as an improper fraction. 3 times 9 is 27, or I can change it to a mixed number. So that's how I got the non-imaginary parts together. Now I'm going to go back up and I'm going to put the imaginary parts together. So I have a negative 3/4 j. That's the only piece on the left that has a j. That must equal the negative 5/4 j minus the yj. So those all have j's in them. Now again, I don't really want the j's to be part of the problem, so I'm going to cancel those out everywhere. I'm just focused on the rest of the stuff. So what you could do is just skip to the part where you're just leaving the j's out, but make sure you put all the stuff that's with them together. So my job here is to solve for y. So I'm going to add the 5/4. So negative 3/4 plus 5/4 is 2/4, which reduces to 1/2. Now that's equal to negative y, so I'm going to have to divide by negative 1. So really my y is equal to negative 1/2. So for each one of these I was able to solve for x and y. Okay, so last but not least, we're on the section where we are going to actually just solve for x as we did up above. Now they may have imaginary numbers in them, they may not. I don't know, I made these up, so let's find out. So most of you at this point are choosing to do the quadratic formula as your method of choice. That is fine. You could still complete the square. Remember, factoring does not work every single time, and in fact it won't work on the top one, and 4 times 21 is 84. I don't know if there's factors of 84 that give me 3 or not. So I'm just going to go ahead and do the quadratic formula. So A is 1, B is 2, C is 3.6. I'm not going to write the quadratic formula out again, I'm just going to plug in. So x equals the opposite of B plus or minus the square root, B squared minus 4 times A times C, all over 2 times A. That's good. We're just going to simplify these by hand. 2 squared is 4. 4 times 1 is 4. 4 times 3.6, I better do this just to make sure. My foggy brain. It's 14.4. 2 times 1 is 2. Go ahead and combine the 4 minus 14.4. I can tell right away since my negative is bigger, I'm going to end up with a negative 10.4. So this is why we did all that practicing before, is how do I break this section down to get as small as I can. So this negative 10.4, how am I going to break that down out of the square root? Well, I know it's negative square root of 1 times square root of 10.4. 1 does me no good, it doesn't help me. I can try 2 squared, or 4 is 10.4 divided by 4. It is, so I can break that out of it. So it's negative 1 times the square root of 4 times the square root of 2.6. Now if you think about 2.6, it's 2 and 13. So nothing's going to go into that that's going to come out anymore. So that's as far down as I can go. So this is my j, this is a 2, this is staying square root of 2.6. So it's going to be 2 square roots of 2.6j. So I'm going to go ahead and put this back into the problem for here. X equals -2 plus or minus 2 square root of 2.6j, all divided by 2. Now, only look at the parts on the outside. Never look inside the square root. I do notice right now that the front 2, the real part, is divisible by 2, and the imaginary part is divisible by 2. So, again, not looking inside the radical. I can go one step smaller, -2 over 2, plus or minus 2 square roots of 2.6j over 2, to get a final answer of -1 plus or minus square root of 2.6j. Okay, so let's go ahead and check out this last one. A equals 4, B equals 3, C equals 21. Now remember, you can always try these yourselves and pause it, and then when you get done, check out and see if we got the same thing. So x equals opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. 3 squared is 9, 4 times 4 is 16, 16 times 21 is 336, 2 times 4 is 8. So my x is equaling -3 plus or minus 9 minus 36, definitely going to be a negative number. It is the square root of -327 all over 8. So we're going to see if we can break down 327. 4 definitely won't work. 9 does not work. So the next one would be 16. 16 does not work. So nothing's going to work. So the only thing we do need to still do is take out the negative though, even though we couldn't break down the 327. So it's going to be -3 plus or minus square root of 327, make sure the j is on the outside of the square root, over 8. Now remember, these all still have two answers because we have -3 plus all this imaginary part over 8, and then we have -3 minus this over 8. So those are still our two answers. Okay, so dig into 14.1. If you have any questions, please let me know and I'll get back to you. Thanks and have a good day.